Hello. All right, so today we got a couple things going on. You have your pre and post test. On the pre-test, you're just clicking true or false. On the post test, this is what you have to do, and it does say it in the directions. You are to choose, write down, is it true or false? If it is false, you have to choose one word and correct it so that you make the statement true. If you do not do that, you do not get full credit. So make sure you correct the one word that makes the statement true. All right, so this week, this is what I have tentatively planned. So today, we have the screencast with notes. You're going to have a close read with questions. This is going to be your activity for the day. You have the pre and post assessments, and then you have a lab, which will be in a different screencast. On Tuesday, you will have another screencast with notes and then an activity. On Wednesday, you will have a screencast on the lab, which will be separate, and the lab, because I'm noticing a lot of you have questions or are not filling out the labs as they are intended. I do go through them on the screencast, so I need you to watch the screencasts. I don't make them just to make them. And they explain how to do everything, so make sure you watch them. On Thursday, screencast with notes. You're going to have an activity and a quiz. The quiz is going to be on Monday, Tuesday, and Wednesday activities, or the notes for them. And remember, on all quizzes, you use your reference table and your notes. And then on Friday, you're going to have another screencast with notes and then a lab. All right, we're going to get right to it. We are looking at a new unit. It is called plate tectonics. I'm going to move my face over here. We have plate tectonics. All right. So, plate tectonics. Sorry, I kind of block out the P a little bit on that. I'll move myself down here for right now. Alfred Wegner. We're going to look at Alfred Wegner. So if you were to look at some of the continents, they look like they might fit together, especially these two right here. And they are Africa and South America. All right. So there's got to be some evidence about this fitting together. Like, how do they do that? Why do they look like they fit together? All right. So, number one, along east coast of South America and the west coast of Africa, we find similar rocks and fossils. In other places like Mount Everest, the tallest mountain in the world, when they finally reached the summit and cracked open some of those rocks, and remember these rocks had to have been some type of sedimentary rock, sandstone, slate, shale, sandstone, shale, could be a little bit of limestone, probably not very much. They found fossils of creatures that lived in the ocean. So they found like creatures that lived in the ocean up on the highest part of the mountains. In places like Antarctica, which is ice covered over land, unlike the North Pole, which is ice over water. So there's two different things. Antarctica is ice over land, North Pole, ice over water. When they crack open the rocks there, they found fossils of creatures that lived in the tropical rainforest. So you have way up in the mountains, creatures that lived in the ocean. Under Antarctica, which is freezing, they found tropical rainforest life, or what was life. All right, so one of the first people to propose this idea was the German meteorologist, not geologist, meteorologist, Alfred Wegner, in the early 1900s. So he proposed this idea that the continents were moving in his theory called the continental drift. Look, right there, although it's not really that way. Okay, so the reason that most scientists, especially geologists of the time, had such a problem with this idea was that it lacked means of force to move trillion tons of rock that made up the continents. So they're like, dude, how can this stuff move? That doesn't make any sense. It's wicked heavy. It obviously doesn't float on water. So how does it move? And so the current idea is called plate tectonics, which views the world as one huge giant plate. Now imagine if you were to drop that plate. Look at this. It breaks into bits and pieces, right? That could all fit back together. So to understand this, sorry, my face is somewhat in the way, you're going to look on page 5 of your reference table, and it is titled Plate Tectonics. So I would like to mention in this unit, you're going to use page 5 and page 10 and 11. Those are huge pages for this unit. So yours is probably gonna look a little better than mine. So it looks like this. It is not colored like the one here. If you would like to, I would highly suggest color coordinating things. Color blue the water if you'd like. And then you have the hot spots right here on this. They have the hot spots purple. You can definitely color that in. When you have these convergent or subducting zones, you could do those with red if you want, or do divergence as blue, transform as yellow arrows. I would so totally do that. So understanding what the plates look like, you look at this page 5. And the continents are all riding on giant plates. And it does say name several plates. So if you were to name a couple plates, you'd got the Pacific plate, the in Australia, the Fiji, the Philippines. One of my favorites is the Juan de Fuca. And then you got the Cocos. And then you got the Nazca. I can't find my favorite. There's another favorite one. You've got Caribbean, Eurasian, African, Scotia, sandwich plate. There you go. That's one of my favorite ones, the sandwich plate. So you've got all these different types of plates. All right, so if Wegner was right and the continents or plates move, then how or what was the force? That was the one huge issue he had. He could not show the force. First, they have to be floating on something, and it can't be water, because the trillion tons of rocks would just sink. Remember, this is where density comes into. Rocks are more dense than water for the most part. I mean, there's a couple that aren't. Pardon me. Instead, they are floating on magma. Just floating does not mean they move, however. So how does it take place? How do they move? What's this movement? How is it moving? Well, just floating does not mean they move. So how does it take place? This is called convection currents, not conduction currents, convection, like convection oven. You're going to notice there's a trend with convection. So convection currents, so hot magma rises up, heated from deep within the earth because it's wicked hot there. It floats, or it finally rises up, gets to the surface or near to the surface, cools. So that cooling magma then sinks down because it's more dense. So it sinks, and then it heats up again, becoming less dense, and then it floats, and it does it, and it makes these convection cells and convection currents. It's almost like wheels on a conveyor belt that pull things along. This is what's moving the plates. So convection currents provide the force for Wegner's drift theory to work, to form one supercontinent, which was called Pangea. There are a couple different types of continents that were formed, and we will get into that a little later. You will see that in a different, the next unit. But looking at this, you can see lots of movement where they're moving apart, and then all of a sudden stuff starts to move together to form what we find today. All right, so that's it for the notes today. Make sure you read and answer the questions, and then what I would like you to do is the lab. Don't forget the post and pre. Those things should take roughly about 5 minutes or so max. If you have any questions, please email or Zoom. Remember, don't forget to Zoom. That is part of your grade. If you have questions, I'm here for you.